Column chromatography is a common and useful separation technique. You will be separating a mixture of the Ferrocenes from the TLC experiment that we performed in Experiment 5. You will be using liquid chromatography. The stationary phase will be silica gel, as before, and the mobile phase will vary. Unlike TLC, liquid chromatography separates from top to bottom. Nonpolar compounds will elute first, and the most polar will elute last. Many compounds are separated this way in industry. Sometimes one solvent system can be used. However, for this experiment, we will use a gradient system to ensure good separation. We will start with a nonpolar solvent to elute the nonpolar compounds first. As the polarity of the solvent system increases, the more polar compounds will also elute. In this experiment, you will be able to see the colors as they elute. This is not true for all compounds. To prepare the column, obtain a column and remove the stopcock at the bottom. Insert a wadded up pea-sized piece of cotton into the bottom of the burette, then reinsert the stopcock. Clamp your column to a ring stand, leaving enough space at the bottom to allow for easy switching of the collection flasks. Clamp the column so that it is as straight as possible so the compounds will run evenly down the column. Close the stopcock. Place a funnel on the top of the column and place a beaker underneath to collect solvent. Add 3 mils of hexanes, followed by a thin layer of sand, about 0.5 centimeters. Weigh 3 grams of silica gel into a small beaker and add to it 15 mils of hexanes. Be careful not to breathe it in. Swirl or stir the mixture well to form a slurry, then pour it into the column onto the hexanes layer. Open the stopcock and allow liquid to drop into the beaker. Using a Pasteur pipette, add a small amount of hexanes to the column to rinse down any silica on the sides of the glass. Close the stopcock when the solvent level is covering the top of the silica layer. If the top surface of the packed silica appears crooked and not flat, tap gently on the side of the column until it flattens out. Add another thin layer of sand. This will help decrease the chances of disrupting the silica when loading the sample. Dissolve around 20 milligrams of the mixture in approximately 0.5 milliliters of ethyl acetate. It is okay if not all of it dissolves, but this will make it easier to separate. Using a long glass pipette and bulb, start to add your dissolved sample to the top of the column. Try to add the solution gently and evenly to avoid disrupting the silica, gel, or sand layer, and ensuring that the sample starts running down the column to form an even level. Open the stopcock and allow the sample to run onto the silica. When the sample is just at the level of the top of the silica, close the stopcock. Gently pipette a very minimal amount of hexane slowly down the sides to rinse down any sample that may have stuck. Be careful not to disturb the silica. When the solvent is at the level of the silica, close the stopcock. If there is no more colored sample stuck to the sides, proceed to the next step. If you still have sample on the sides, repeat the rinsing again with hexanes in a very small amount. Once the sample is loaded onto the column, you can very gently add 15 mils of hexanes to the column and start the separation. This is your non-polar solvent that you'll be starting with. Again, make sure to avoid disrupting the sand and silica when adding the hexanes. Open the stopcock and watch for the first color to elute from the column. Add more hexanes as needed, making sure not to let the column run dry or crack. Once the first color has come off of the column into your Erlenmeyer flask, Switch the solvent system and add about 10 mL of the 80% hexanes, 20% ethyl acetate mixture and watch for the color to elute. If you need more, you may add more as necessary until the second band comes off. After the second color comes off, if the third color has not eluted from the column, proceed with the 50% hexanes and 50% ethyl acetate. Collect the 3 colored fractions in clean glass Erlenmeyer flasks and label each of them clearly. Once you have collected all of the samples, confirm the identity and purity of each of the fractions by running TLC analysis against pure samples of each material as you did in Experiment 5 with the TLC plates. Once you have identified your fractions, empty the silica into a beaker by turning the column upside down and gently tapping. If the cotton ball is stuck, take the burette tip off and remove it with a forceps. Clean the column with acetone. Do not set up your column at an angle. Your samples will elute crooked. Do not add too much hexanes when trying to load your sample. This will not allow for a good separation. You can see here, because the sand level is crooked, the sample is also running through crooked. Do not allow your column to run dry. It will crack.